1940 issue order type 247, fuse cleared, 1 tape snag, 1 safety pin pulled, impact came early, failure entered the report. The inspection note was sealed that night. By mid-1940, Britain expected invasion. The setting was the British home front. The British Army had left guns in France. Dunkirk evacuation had ended weeks earlier. Anti-tank ammunition shortages blocked live training. Home Guard units needed cheap anti-armour weapons. Factories also faced urgent dispersal instructions. Procurement offices demanded rapid deliverable designs. Engineering teams prioritised simple hand-thrown charges. The War Office issued fast interim requirements. Those requirements accepted high user risk. They emphasised damage against tracks and suspensions. The period also saw limited shape charge supply. British industry already rationed metals and tooling. Glass and simple tins remained easier to source. Explosive filling stocks were unevenly distributed. Distribution depended on rail capacity under air attack. Storage depots faced strict segregation rules. Local commands requested weapons without specialist crews. Anti-tank rifles lacked effect on newer armour. Field guns were too few for every roadblock. Stopgap weapons were therefore procured in batches. One outcome was the No. 73 grenade. The device gained the nickname Thermos. The shape resembled a common thermos flask. It was classed as an anti-tank grenade. Service introduction occurred officially in late 1940. The initial issue targeted invasion defence units. The intent assumed close ambush positions. The system relied on a heavy explosive mass, and its mass created handling limits for soldiers. The same mass drove bureaucratic arguments about utility. Reports noted short throwing distance in use. Training notes required cover before detonation. That requirement constrained employment to prepared positions. The grenade was also called a Woolworth bomb. The War Office still treated it as lethal ordnance. Design responsibility sat within standard ordnance channels. The goal remained immediate impact detonation. Impact initiation avoided time fuses in training. It also reduced reliance on clockwork timers. Clockwork timers needed precision machining capacity. Machining time was reserved for other priorities. Percussion fuse could be produced quickly. The No. 73 adopted an always fuse. Always meant detonation regardless of landing attitude. Now, this characteristic reduced misfires from orientation errors. The approach still carried risk to the thrower. Short range increased blast hazard to users. War Office manuals stressed ambush and roadblocks. The manual described best effect on tracks. The manual also warned about exposure during throw. Late 1940 production occurred under invasion alarm. Component supply chains were frequently disrupted. Procurement files preferred assemblies with few parts. Its body used a simple cylinder. A plastic screw cap sealed the upper end. The cap also supported the external fuse fitting. The overall length was about 11 inches. The diameter was about 3.5 inches. The total mass was about 4.5 pounds. Explosive filling weight was about 3.5 pounds. The fillings included polar aminal gelatine dynamite. Some versions used a nitrogelatine explosive filling. These fillings were highly flammable by nature. Small arms impact could initiate the filling. That property complicated storage and transport rules. Transport packaging required shock and heat protection. Quartermasters recorded strict separation from ignition sources. The external appearance still suggested a household flask. That resemblance aided concealment in the civilian spaces. It also increased accidental handling risks. Units demanded clear markings during distribution. Instruction leaflets were issued with each batch. Leaflets described arming steps using a tape. A weighted tape was held in the hand. The tape unraveled during the throw. Unraveling tension pulled free a safety pin. The safety pin was linked to the fuse. The fuse type was type 247. So type 247 was an always percussion fuse. Removal of the pin armed the fuse. Subsequent impact initiated the detonator train. This design avoided a separate striker cocking step. It also reduced user steps under stress. The tape method still imposed strict handling discipline. If the tape snagged, timing became unpredictable. Early tape slippage caused premature arming. Training therefore emphasized controlled release procedures. Some units practiced with inert drill items. Ammunition scarcity limited realistic practice elsewhere. The range was limited to 10 to 15 yards. This range matched field notes and manuals. Such distance required near contact with vehicles. That requirement increased casualty probability for operators. Commanders therefore assigned it for prepared ambushes. Roadblock teams used cover and concealment. The explosive power could damage light tanks. Penetration was listed as about 2 inches. Penetration claims depended on impact location. Tracks and suspension offered more reliable results. Direct hull hits had uncertain practical effect. The intended effect was mobility kill. Mobility kill delayed columns at choke points. Delay supported follow-on fire from other assets. The grenade was therefore part of layered defense. The weapon entered service during equipment scarcity. It was withdrawn within about a year. Withdrawal followed assessment of limited throwing range. Alternative weapons entered service by 1941. The No. 74 sticky bomb competed for role. The Piat later provided safer standoff effect. Yet the No. 73 remained in depot stocks. Ordnance officers reassigned it as demolition charge. This reassignment reflected its large explosive mass. Removal of the fuse enabled controlled initiation. The body could then serve as a charge container. Demolition use increased in later war years. Reissue occurred again during the year 1943. The stated purpose then was demolition work. This shift aligned with evolving training doctrine. Demolition tasks prioritized reliable charges over throwing. Ordnance policy also favored standardized components. The No. 73 still presented handling hazards. Its fillings remained sensitive and flammable. Storage required temperature control when possible. Depot logs recorded segregation by filling type. Transport regulations restricted carriage in some vehicles. Lorry commanders were briefed on fire risk. Packaging used padding to limit impact shocks. The No. 73 benefited from early urgency. By 1941, early urgency shifted toward ranged weapons. That shift reduced emphasis on heavy hand bombs. When reissued for demolition, fuses were optional. Field engineers preferred predictable initiation systems. Predictable initiation required standard detonators and switches. Special forces also required delayed initiation devices. Delayed initiation enabled distance and deniability. It allowed planting charges without immediate engagement. The British developed pencil detonators for this role. Pencil detonators were also called time pencils. They were introduced during World War II. Development occurred at Aston House in Hertfordshire. The device matched an ordinary pencil in size. This size allowed concealment in clothing or kits. The No. 10 delay switch was one type. Its official name was switch number 10 delay. The outer tube was commonly brass. The later versions used aluminium for economy. A copper section contained a glass vial. The vial held a cupric chloride liquid. Reports sometimes misidentified the liquid as acid. A spring-loaded striker sat under tension. A thin metal wire restrained the striker. Activation required crushing the copper section. Crushing broke the vial and released liquid. Released liquid began to erode the wire. Erosion progressed until the wire parted. Wire failure released the striker abruptly. The striker drove into a percussion cap. The percussion cap initiated the attached detonator. Delay was set by wire composition and design. No. 10 delays ranged 10 minutes to 24 hours. Accuracy varied with each delay period. Short delays could be accurate within minutes. Longer delays had larger variance windows. An ambient temperature strongly affected corrosion rate. Cold conditions could lengthen a 24-hour setting. Hot conditions could shorten a 12-hour setting. Issue packs included temperature correction charts. Charts were issued without a thermometer. Operators needed judgment for correction use. Failure mode included early release before stripping. An inspection hole could reveal striker position. If obstructed, the switch was discarded. Field doctrine sometimes used 2 switches per charge. 2 switches reduced single-point failure probability. This redundancy increased material consumption per mission. Mass production later reached millions of units. Figures cite about 12 million produced in Britain. Such volume indicates standardized manufacturing methods. Manufacturing relied on tubing, springs, and wire. The copper section required precise crush behavior. The wire needed consistent corrosion characteristics. Cupric chloride concentration needed stable batches. Ampules required reliable sealing for storage. Leakage would spoil timing and contaminate explosives. Quality control therefore inspected for obstruction and leaks. Packaging separated switches from detonators in transit. Detonators were issued under separate accounting rules. Integration occurred at user level near target. This reduced risk from accidental initiation. It also increased training burden on operators. Training emphasized leaving the area after insertion. The same timing logic suited demolition charges. Demolition charges could include repurposed grenade bodies. The number 73 body could accept a detonator well. Removal of the always fuse created an opening. An adapter could link detonator to explosive charge. Documentation varies on field improvisation practices. Some improvisations used standard primers and caps. Other practices used issued detonators and safety fuse. Where time pencils were available, delay initiation was possible. Delay enabled detonation after withdrawal from the site. Chemical delay avoided ticking sounds and moving parts. No clockwork reduced mechanical failure from dust. Compact size aided carriage across checkpoints. A chosen delay supported alibi creation. The grenade remained overtly military in appearance. Its primary use required open engagement distance. That difference shaped how each device was employed. The grenade demanded close approach to armoured vehicles. The time pencil supported covert placement activities. And both reflected British wartime improvisation constraints. Both also showed risk acceptance within procurement. Throwing distance defined the grenade's primary risk. Timing variance defined the time pencil risk. Engineering analysis treated both as system problems. For the grenade, physics limited human throwing range. Mass and shape reduced attainable release velocity. The Thermos cylinder lacked stabilizing fins. Trajectory therefore depended on user strength and grip. Wind and wet conditions further reduced accuracy. Operators were instructed to throw from cover. Cover reduced view of target at release. Reduced view increased miss probability against tracks. Misses wasted scarce grenades and exposed operators. Impact detonation also required direct contact. Soft ground could absorb energy and reduce effect. Ricochet behavior was unpredictable on hard surfaces. A fuse could detonate on ground before target. Such early detonation endangered friendly personnel nearby. Safety guidance insisted on clear throw arcs. Crowded roadblocks often created additional handling hazards. Units sometimes allocated one thrower per grenade. That reduced handling by multiple individuals. The fuse arming tape also needed space. Obstacles could snag the tape during throw. Snagging could pull the pin prematurely. Premature arming before release was hazardous. Therefore, the tape was kept controlled until release. Some training manuals describe strict hand positions. The Type 247 fuse required correct seating. Loose seating could cause failure on impact. Overtight seating could damage threads and cap. Plastic cap threads could strip under rough handling. And stripped threads compromise sealing against moisture. Moisture could degrade explosive filling stability. Dynamite-based fillings could weep under heat. Weeping increased sensitivity and handling risk. Procurement also faced competing explosive priorities. Polyammonal was needed for other charges. Nitrogelatine was used in many demolition tasks. Allocating 3.5 pounds per grenade was costly. Clerks calculated issue based on operational value. Short range reduced cost effectiveness in many units. This drove removal from anti-tank role. However, demolition reuse preserved some utility. As demolition charge, throwing limitations were irrelevant. A charge could be placed by hand directly. Placement allowed packing against structural weak points. Weak points included rails, girders, or columns. The large explosive mass suited cutting metal. Detonator placement affected bristance transfer into targets. Engineers used tamping material when available. Sandbags or earth improved cutting efficiency. Time constraints often removed tamping opportunities. In such cases, higher explosive mass compensated. The number 73 container provided convenient packaging. Convenience reduced time at the emplacement site. Time reduction decreased exposure to patrols or fire. In the field, initiation choices were critical. Instant initiation required immediate withdrawal under stress. Delay initiation allowed controlled retreat to safety. Time pencils offered one delay option. Another option was safety fuse with matches. Safety fuse provided less precise delay times. Clockwork timers offered precisions but demanded maintenance. Chemical delay devices avoided moving mechanical parts. Their simplicity fit austere operational conditions, yet temperature sensitivity remained a known limitation. Cold slowed corrosion and extended delay. Hot accelerated corrosion and shortened delay. Operators used correction charts without instruments. Such estimation introduced systematic timing errors. In sabotage operations, operational deniability mattered greatly. Delayed effects allowed agents to depart unseen. Within British Command, evaluation relied on reports. Reports included failure rates from environmental extremes. Reports also covered premature detonation incidents. Premature incidents drove stricter handling rules. Safety memos often followed such accidents. Safety memos adjusted packaging and instruction text. For the number 73, accidents included close blast injury. Her manuals therefore repeatedly stressed cover requirements for throwers. Cover requirement reduced chance of immediate observation. Reduced observation reduced probability of accurate throw. This trade-off was accepted under invasion conditions. Invasion conditions prioritized any anti-tank capability. When invasion threat reduced, standards tightened. The number 73 then fell from priority lists. Procurement offices redeployed resources to PIAT production. PIAT offered increased standoff and repeatable drills. Demolition stock still included remaining number 73 bodies. This demolition role persisted into later war. A notable modified use occurred in Prague. A shortened number 73 was used in 1942. The bomb was thrown at Heydrich's car. Modification reduced weight for concealment and throw. This event highlighted flexible use of the body. It also reinforced ordnance interest in compact charges. The modified version differed from standard service issue. Standard service issue remained heavy and awkward. Field users continued to report low throwing distance. Bureaucratic correspondence noted limited tactical scenarios. Roadblocks and ambushes remained primary scenarios. Ambush positions often required pre-dug cover nearby. Cover construction required engineer and labor resources. Home Guard units had varied training levels. Varied training increased accident potential with impact fuses. Impact fuses also complicated transport during exercises. Therefore, many units preferred later, safer systems. As demolition charges, number 73 bodies could be carried. Carriage still required protection from small arms fire. Small arms fire could detonate sensitive fillings. This posed risk during contact with enemy patrols. Operational planning therefore avoided carrying in open firefights. Charges were transported under controlled conditions. Investigations rarely produced public summaries for these accidents. Internal memos adjusted training emphasis instead. For the time pencil, investigation focused on timing drift. Timing drift was correlated with temperature exposure. Charts attempted to correct expected drift. Absence of thermometers limited practical correction. Some users improvised by estimating ambient conditions. Such estimation introduced additional operational uncertainty. Despite uncertainty, simplicity supported widespread adoption. Mass production shows institutional confidence in the design. Institutional confidence still included redundancy instruction. Redundancy implied an expected failure probability in service. This frankness matched British sabotage doctrine. Sabotage doctrine accepted occasional failure in exchange for stealth. Stealth reduced risk of capture and compromise. Capture risk also depended on device traceability. Time pencils carried distinctive construction materials. Copper, brass, and tubes could be recognized. Therefore, agents were trained to discard damaged switches. Damaged switches could reveal methods if found. Discarding also prevented accidental early firing. Early firing could kill the operator during assembly. Thus, safety and security overlapped in doctrine. The number 73 had fewer concealment advantages. Its size made clandestine carry difficult. It remained a field weapon or charge container. Yet the same explosive mass drove its selection. And the Thermos body could be pre-positioned in defenses. Pre-positioning reduced exposure during an attack. Pre-positioned charges still needed initiation plans. Initiation plans included impact, fuse, or delay. Impact suited immediate anti-tank ambush tasks. Delay suited demolition of bridges or rails. Selection depended on command intent and access. Explosive theft risk was treated as serious. The Thermos grenade was easy to misidentify. Misidentification risk required education and warnings. Warnings were printed in training documents. Training documents stressed lethal blast radius. Blast radius was dangerous within short throwing range. Thus, a weapon meant to stop armor-endangered users. This contradiction shaped later weapon policy. Policy moved towards standoff launchers and mines. Mines could be placed with distance and concealment. The mines also used pressure or tilt fuses. Those fuses allowed placement without direct throw. Mines demanded more complex casings and detonators. Complexity was accepted once industry stabilized. In 1940, industry lacked that stabilization. Hence, the number 73 represented an emergency solution. Emergency solutions carried predictable trade-offs under wartime pressure. One trade-off was weight against explosive effect. Another trade-off was sensitivity against ease of manufacture. A further trade-off was the training against scarcity of ammunition. These trade-offs were recorded in withdrawal decisions. Withdrawal did not imply complete uselessness. It indicated mismatch with frontline anti-tank needs. Demolition tasks still extracted value from stock. Stocks were reissued when demolition demand rose. Demolition demand rose during offensive operations. Offensive operations required rapid destruction of infrastructure. Rail demolition supported interdiction and delay. Depot demolition prevented capture of supplies. Charges needed predictable performance under field conditions. Predictability required standardized detonators and initiators. Chemical delay switches provided one standardized initiator. They avoided clockwork production bottlenecks within British factories. They also avoided audible ticking at the site. Chemical delay still varied with temperature. Temperature variation was accepted with correction charts. Correction charts were imperfect but useful. This bureaucratic acceptance reflected wartime pragmatism. Pragmatism also governed the number 73 legacy. The number 73 was powerful yet awkward to throw.